SwayamPrabha. Digital India. Educated India.
Today we'll learn about Hansa 3 aircraft, which is an NAL manufactured aircraft. Hansa 3 is an all-composite, low-wing, single-engine aircraft which is equipped with fixed tricycle landing gear. It consists of a conventional primary controls, namely aileron, elevator and rudder, and secondary controls which are flaps and tail. The primary controls are manually operated by a dual interconnected set of control sticks which can be seen inside the cockpit, and a rudder pedal which is also located inside the cockpit, whereas secondary control has a manual and an electric operation. There are two integral side-by-side seats for pilot and co-pilot. This aircraft is powered by a Rotex 914 F3 engine, which is a 4-stroke 4-cylinder horizontally opposed piston engine. The aircraft is equipped with a variable pitch 2-bladed constant speed Hoffman composite propeller. The length of this aircraft is 7.6 meters and its height is 2.6 meters. Its maximum takeoff weight is 750 kgs. It has a fuel tank which is fitted behind the pilot seat with a tank capacity of 91 liters, of which 85 liters is usable. The aircraft is equipped with a variable pitch 2-bladed constant speed Hoffman composite propeller. The length of this aircraft is 7.6 meters and its height is 2.6 meters. Its maximum takeoff weight is 750 kgs. It has a fuel tank which is fitted behind the pilot seat with a tank capacity of 91 liters, of which 85 liters is usable. So this is the brief introduction of Hansa 3 aircraft, which is NAL manufactured. Now, whenever we think about the aircraft's description of the structure, we intend to say that the internal structure comprising of the item of equipments and the various instruments on the cockpit panel, and the external structure which consists of the wing, the primary control surfaces, the secondary control surfaces, the landing gears, engine and the propeller. The most important part of an aircraft is the wing, that is a lift producing device. The wing of Hansa 3 aircraft is a single piece wing with 3 spars, the leading edge spar, main spar and the rear spar. It is of composite construction with a span of around 10.5 meters, consisting of a primary control surface aileron attached to a wing and a secondary control surface flap which is located inboard side of each wing. Flap is located inboard side of each wing, which is a secondary control surface used at the time of landing and as well as the time of takeoff. So after the wing, the main plane comes the tail plane, which consists of a horizontal stabilizer, that is a fixed surface, to which is attached a movable tail surface, that is an elevator, and a vertical stabilizer, which is again a fixed surface, to which it is attached a movable surface, that is called rudder. So this is the elevator movement and this is the rudder movement. Now when we get to know about the elevators, elevators are the primary flight control surfaces which are usually at the rear of an aircraft. Elevators are usually hinged to the tail plane or horizontal stabilizer, which is a fixed surface. They controls the aircraft pitch, that is movement of aircraft about the lateral axis. And when we talk about the rudder, rudder is a directional control surface. The rudder is usually attached to the fin or the vertical stabilizer, which is a fixed vertical surface. They control the yawing motion of the aircraft, that is movement of aircraft about the vertical axis. The movement of the rudder is provided by means of rudder pedals, which is provided in the cockpit. The forward and aft movement of pedals is transmitted to the rudder pedals, to the rudder controls by means of bell cranks, levers and push-pull rods. Pressing the right rudder pedal turns the control surface towards right, thereby which an air pressure acts upon it, which in turn forces the tail left and nose of the aircraft towards right. All primary controls are mass balanced and are provided with stops to limit the respective range of the controls. The primary control surface which is attached to the wing is known as aileron. It is a hinged flight control surface usually forming part of the trailing edge of each wing of a fixed wing aircraft. Ailerons are used in pairs to control the aircraft in roll, that is, movement of the aircraft about its longitudinal axis, which normally results in a change in flight path due to the tilting of the lift vector. Movement around the axis is known as rolling or banking. The sideward movement of the control stick transmits motion to ailerons by means of lever, bell cranks and push-pull rods. The normal range of the movement of aileron for Hansa 3 aircraft is 20 degrees up and 20 degrees down. As we can see, when the control stick is moved towards left, the left aileron raises up whereas the right aileron goes down. The left aileron, which is going up, creates drag, whereas the right aileron increases the surface area and hence raises the right wing, whereas the left aileron goes down, lowers the lift towards the left wing, and hence the aircraft rolls towards the left. Wing flaps are manually operated by means of a control handle provided in the central pedestal located in the cockpit. The movement of the control handle is transmitted to the flaps through torque tubes, bell cranks and push-pull rods. Wing flaps in this aircraft is a single slotted Fowler type flap. It has a 10 degree and a 20 degree down position. Flaps can be used at the time of takeoff and as well as the time of landing. Trim tab, which is located on the left elevator, is provided to aid the pilot by assisting in operation of primary control surfaces and also to keep the aircraft balanced. It is operated by an irreversible electrical actuator which is located inside the horizontal stabilizer, which is directly attached to the operating lever of the tab and is located on the LH side. This is all about the controls and the structure, external structure of Hansa 3 aircraft. So here comes the instrument panel of Hansa 3 aircraft. We can see the various instruments installed on the instrument panel. We will start with the primary flight instruments, that is airspeed indicator. This is airspeed indicator which gives the reading in knots. Then we have altimeter which tells us the height, and this is the vertical speed indicator, also known as rate of climb indicator, which tells us the feet per minute. ASI, altimeter and vertical speed indicator. These three are the method static instruments, out of which altimeter and vertical speed indicator inputs the static pressure, whereas airspeed indicator takes the total pressure, the dynamic pressure and plus the static pressure. Then we have the gyro instruments, gyro horizon. We have engine instruments, that is the manifold pressure gauge. This is the tachometer, also known as RPM indicator, which tells us about the RPM of the engine. The static RPM for this engine on ground is around 2250 RPM. Then we have the ignition switch over here. We have various indicators for CHT, that is cylinder head temperature indicator. We have an oil temperature indicator. We have an oil pressure indicator. Also we have a turn coordinator. In line with it is a level indicator which tells us the aircraft is aligning towards left or towards right. You can see the markings on the gauge as L or R. So this is a turn coordinator. Then we have various switches for lights, for electrical panels. This is the radio communication set for this aircraft. Above you can see the magnetic compass, and just this is the outside air temperature gauge. So magnetic compass gives us the heading where the aircraft is moving. Outside air temperature tells us the free air temperature of the air, and the various gauges gives us the reading which helps the pilot to maneuver the aircraft properly. Below here you can see the various controls, that is the throttle control and the propeller control. Here's the choke, activate. Then we have this is the flap lever. This is the choke which is used to activate the engine. We have the throttle controls, we have the propeller controls. Propeller controls to make the propeller pitch fine or coarse. It is having a constant speed propeller, so pitch can be changed. And this is the throttle which can be set it on idle, on 100% and 115%, that is the max RPM. This is the lever for flap, which has 3 positions: up, 10 degrees and 20 degrees. Up is when flap is fully up, 10 degrees is when flap is retracted downwards to 10 degrees, and 20 degrees is when flap is retracted fully towards downwards, that is 20 degrees. 10 degrees is used at the time of takeoff to increase the surface area of the wing and to increase lift. 20 degrees is used at the time of landing to increase more drag and thus provide safe landing in a minimum distance. This is the control stick which is used to operate the primary flight controls, the aileron and the elevator. Moving it towards left or right gives the movement to the aileron and thus a rolling motion to the aircraft. Moving it forward or aft gives the pitching movement to the aircraft, that is to the motion to the elevator, and thus an aircraft pitching takes place. Below you can find rudder pedals there. Here these are the rudder pedals moving towards left or right, and when these are to be used on grounds, both of them are pressed together to give a braking action to the aircraft, and in air these serve as yawing motion. This gives an yawing motion to the aircraft. Pressing the left rudder pedals gives the motion of the aircraft, motion of the control surface towards left. Pressing the right rudder pedal, when right rudder pedal goes forward, the rudder moves towards right and accordingly gives the yawing motion to the aircraft. As I mentioned, behind the pilot and the co-pilot seat there is a fuel tank with a tank capacity of 91 liters. This is the location of the fuel tank. Beneath this is a fuel tank. Its tank capacity is 91 liters, out of which 85 liters is the usable fuel and 6 liters is unusable. Whenever an aircraft passes through the lightning atmosphere, there is a protection provided on the aircraft to protect its surface from lightning ill effects. So on this Hansa 3 aircraft there are 6 lightning arresters which arrest charges and passes on them to ground the charges. There are 6 lightning arresters, 2 in the form of a triangular plate which are located on both sides of the wings, 1 on top of the fuselage as an aluminium rod, and 3 on the 3 landing gears, the 2 main wheels and the nose gear. These 6 arresters in all carries away the charges and grounds them to the surface so that the aircraft surface is protected from any lightning strike. The aircraft is flown in daytime and as well as in night. So there are certain lights which are provided on the aircraft surface to aid the pilot to fly the aircraft and also to aid the pilots of other aircraft which are flying in the airspace in or around the aircraft. So we have navigation lights located on the wing tip. The left side, that is a port side, contains a red light. The right side contains a green light. On top of the rudder there is a light which is blinking all the time, and that is known as an anti-call light, that is anti-collision light.